Right, for today's notes, we're getting a notification that there is an outage in certain neighborhoods, so I thought I would go ahead and pre-record it in case you're watching this later or from your phone. So we're doing a quick notes today, and then the Apex quiz is optional extra credit. Our quiz is actually going to be on a Google Doc that you'll see pop up, assignment number 62. So let's talk about imaginary numbers and why we have these things. I hope you did the study guide already. It was a nice short one just to give you an intro to this. But when we go to try to take the square root of a negative number, for many thousands of years, mathematicians and people just thought that this was something that was impossible. There is no number times itself that could equal -1. So when we have an index of 2 or a square root of -1, the answer for many thousands of years was no solution. But then some mathematicians came up with some other ideas. For example, we can find any quadratic does have zeros or a place where x is equal to 0. So what I mean by that is, what if we were trying to solve x squared plus 1 equals 0? This is a quadratic, and any quadratic has some value of their zeros, meaning when y is equal to 0, and I want to solve this one. So if I subtract 1 to both sides, and I get x squared equals -1, and I square root both sides, mathematicians were posed with this question of, how do I represent this? I need something to represent this because this is my 0. Even though this 0 does not touch on the x-axis, it is not a real root. It doesn't fit in the real number system. Even though it's not a real root, I need a way of representing this 0. And this 0 would be the example of a graph that never touches the x-axis. But what are these roots, these two places where the x values are equal to 0? How can I represent those? And that is where the imaginary numbers came into play. So they gave it this general definition. The square root of -1, we're just going to call it I, this imaginary number. And then there's a couple of other properties that go along with this. For example, if we said I squared, that would be the square root of -1 times the square root of -1, or I times I. So we realize that the square root of -1 squared is just equal to -1. So we can say that I squared is equal to -1. So far we have two definitions. I equals -1 square rooted, and I squared equals -1. Well, let's go do I to the third. That would be I squared times a plain I, and we know that I squared is -1. So -1 times I is just -I. And finally, let's go do I to the fourth. I to the fourth would be I squared times I squared, and we know that I squared is -1. So -1 times -1 is just 1. So let's go write these down here. I equals square root of -1. I squared equals -1. I to the third equals -I, and I to the fourth equals +1. What happens after this is it begins to repeat infinitely. So if I go to do I to the fifth, it's really like saying I to the fourth times I, and 1 times this would just give you this, etc., etc. So I to the fifth would repeat back to here. So here's I to the first, second, third, fourth, and we could go 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, and those is what it would be equal to. So these are the properties that we use to simplify imaginary numbers because they just keep repeating themselves infinitely. Let's go look at a couple of examples here. Normally, if we have the square root of a number like 9, the answer would be 3 or plus or minus 3. But now we're asking about imaginary numbers or the square root of -9. So this is going to get broken up into the positive root and the root of -1. Notice that those two factors, if multiplied, would be back underneath as -9. So the square root of 9 is just 3, and by definition, the square root of -1 is just I. So my answer here would be plus or minus 3i. So let's go try a couple more. Try the square root of -16 and the square root of -25. Again, we break it up into the positive root and the root of -1, the positive root and the root of -1. What is the square root of 16? It is plus or minus 4. What's the square root of -1? It's I. And same for over here. It would just be 5i. Now, what if the radicals need to be simplified, but they're not perfect squares? So what if we have the square root of -48? What if we have the square root of -27, for example? So break these up into what times what equals 48. So for example, 48 is 16 times 3. Well, don't forget we have this -1 now. So the square root of 16 would be plus or minus 4. Square root of -1 is I, and then we leave the root 3 underneath because there's nothing that we can take out of root 3. This one would break up into the square root of 9 times 3. Don't forget that there's now a -1. Square root of 9 is plus or minus 3. Square root of -1 is I, and then leave the root 3 underneath. You try one. Square root of -50. Pause the video and try it. See if you can get this simplified radical. So square root of 25 times 2, and then square root of -1 because it's a negative. 5i root 2. How'd you do?